This video series is about understanding Mifare Ultralight Tags. Mifare Ultralight Tags are manufactured by the company called NXP. This is going to be a multi-part series because I will be covering the concept in very much detail. I've already made few videos on the same tag, and they're also available in YouTube. I'm going to show them in a bit. I'm going to follow a certain order in this video. First, we are going to understand the memory structure of the ultralight tags. Then we are going to see the activation sequence and the transition diagram. We are going to understand what are locks and why are they used for. And we are going to see what is OTP. It's also called one-time programmable, and the user memory. And we are going to see what to do when there are errors. So these are the three videos on ultralight tag I made. If you see this video is about using ultralight tag along with Arduino and Mifare C522, and what you see here is my software used to understand these tags. And if you look at the date, this was done on 27th of Jan, almost or more than 2 years ago. The next video is again the second part, and this is also done in a more or less 2 years ago. And I've done one more video, but this time using the OmniKey 5421. This is also a reader writer, and this is a fairly new videos which was done probably a month ago, and this is the fourth video, and this time I'm going to cover everything in detail so that I don't have to make any more videos on this concept. So why you have to start with ultralight tags, and who are going to benefit from these videos? Ultralight tag is the easiest among all the tags produced by NXP. The reason is easiest is there is no password, there is no encryption, decryption, or some buzzwords like a 3DS or authentication. There's nothing like that. And if you want to buy them, they're also cheaper to buy, something around 25 to 35 pence, and available in plenty. You can buy them from various websites. Even now, these tags are used as a travel ticket or event ticket or a single entry train ticket, etc. I have done few projects where this tag was used as an event ticket. So it's going to benefit all undergraduate students who are doing their computer science, electronics, or electrical engineering. I was a teacher long ago, teaching undergraduate students in computer science as well. So the students of diploma, they can also benefit from this. Probably you can after understand the concept, you can create projects. Any software developers who want to integrate the NFC tags into their existing or new applications, or electronic hobbyists who work with the microcontrollers. So to play with the Mifare Ultralight tags, you must buy the reader writers. You can build your own reader writer using the Arduino microcontroller, and using Mifare C522 reader. You can also use a PN532 or the OmniKey reader writer. These are the finished products, and ACR122U. Or you can also use this CR95HF based boards, and this is the one I'm going to use here. And you need a copy of Mifare Ultralight document, and which you can get it from the NXP website. And you also need, because I'm using CR95HF, and you can or you need this CR95HF development software as well. So I made, if you see my previous videos, I've now covered a few things about how to use this software. So what you see here is the Mifare Ultralight or documentation, and the section 7.5 shows the memory organization of this tag. So the memory structure is very simple, and this has got 16 pages of data, and each page has got 4 bytes. And as you can see here, the page 0 has and page 1 have the serial number, and page 2 has got the log bits, and you can see that the last byte of the serial number is also in the page 2, followed by the OTP and followed by user memory. So the memory is very straightforward, as you can see here. So let's go and see the same memory structure using the actual tag. So I'm going to use the CR95HF tag here, board here. So we have seen my other videos where we have covered some of the features of this board. So let us do it. So I have connected my CR95HF board. I'm going to place a brand new ultralight tags here, ultralight tag, and this is the software I have written using Visual Basic, .NET, and I'm also using the library that comes with this board, that's CR95HF, the DLL. The first thing you're going to do is I'm going to connect it, and here, so I got two options here. So I already made a video on how to use CRIX 4K, and I'm going to choose the Mifare Ultralight. So the first thing you're going to do is I'm going to activate the tag. So when hit this activate, so I know that the tag is activated and it is ready for the read and write operation. So I'm going to bring this entire 16 pages of data into this program by clicking on this read tag, and you can see that this is the content of a brand new tag. So this has got 16 pages from 0 to 16, and you can see this is the page data. Each page has got 4 bytes, B0, B1, B2, B3, and on the top here this is the UID of the tag, and as you can see here the log bits, you got a log bits here. So in order to understand this better, I've got a nice structure of the locking. So using these log bits you can lock any data here, and likewise you got the OTP, so you can play with the OTP, and all this read and write is happening using the DLL. And please see my other videos on the activation and anti-collision using a Mifare or Type A tags. And if you see here, you'll come to know exactly what is happening within the software. So I've just started with the antenna off, then setting this protocol A, and all these are the commands that is going from my software to this board. And next thing is we need to send these commands. I covered this in my previous videos, and this is where everything, all the anti-collision or selection happens. So the first is the REQA. I'm not going to cover this REQA here because I've made a separate video on explaining what REQA is. So what's happening here is the REQA request A, anti-collision 1, select 1, anti-collision 2, select 2, and you can see all the bytes going here. And after that I'm reading, there's a read page 0, page 4, page 8 and page 12. Each page read operation brings 16 bytes of data, or the 4 pages of data. So I have got 4 read commands here. So it's very straightforward. So I'm going to show you next how to play with the this tag, and also at the same time You're also going to see what are the various commands that are used, and all the various functions of CR of this DLLs used as well. Next, I'm going to show you how to understand this the state diagram. So we have seen little bit of this in my previous videos on anti-collision and selection using type A tags. So this diagram is it looks complex, but it is pretty straightforward. You just have to follow a one path at a time. So let us start what exactly happens when I bring the tag into this RF field. So when I move this tag into this the reader RF field, the tag is powered. Now when the tag is powered, it will automatically move to the idle state. Now while it is in the idle state, the diagram here says the tag can respond or can understand only REQA or WPA command. That's all. Now assume that the reader, when I say we, sorry, the reader sends the REQA command. Now the tag, after receiving this REQA command, will make a transition to the ready one state. So now the tag is still in this idle state because we have not sent any command. So while the tag is in the ready one state, when it receives the command called select command, it moves to ready 2 state. While it's in the ready 2 state, when it receives the command called select, like one more select, it moves to the active state. So in order to read and write the memory content of this tag, the tag must be in the active state. So the tag takes the path from power on. So it started from here, power on, idle state, went to ready 1, ready 2, and active state. So here, because there are two select commands here, and these are called as the select 1 command and select 2 command. So this is how the tag starts from the POR and the active state. So let us revisit this command. Let's go to my software and see what has happened. So I'm going to close this window and start again. So I'm showing all the commands that are going from the software in this commands tab, and when I hit this activate state, so let's see, if you can ignore these bits here, because this is all to do with configuring the board. And the first thing is REQA command, and you know that the REQA, the actual command code for REQA is 2607. I'm going to spend some time explaining to get how did you get this 2607. The card responded something here, and which I covered in my videos on anti-collision as well, but I did came to know something more about this 07 and other bits I'm going to explain now. The next is, so here if you go back to this in REQA, the tag has responded, and let's go. So now the tag has responded, that means the tag is in the ready state 1, and here there is a small loop here. This is called as the anti-collision command. So when you send the anti-collision command, the tag will respond, and let's see what it does now. So here we have sent the anti-collision 1 command because there are two anti-collisions in the diagram. It is called as a 1 and 2. So the tag has received the anti-collision command, and it has responded with some output here. And Now we know where the tag is. So if you go back to the diagram, so the tag is still in the ready one state, but it has gone through the anti-collision command. The only way now, as of now, to come out of this ready one state is after receiving this select command level 1. So next, I'm sending this select one command, and the tag has responded with the this is the positive response. And let's see where we are. So we know that the tag is now in the ready to state, and we have to send one more anti-collision command, and after that one more select command. So here we have got this the anti-collision 2, and the tag has responded with the positive response here. After that, the select 2, there is a positive response here, and now we know that the tag is in the active state, so we can read and write using the various commands of ultralight. So I'm going to clear this locks here. If I hit read, now the read is successful because the tag is in the active state. Now just to try that, I'm just going to lift the tag, and let's see what happens now. I'm going to try again, read the tag. Look at that. So there's no response. So because the tag has react means it is not powered, and we have to start all over this sequence again. So next I'm going to show you how to activate the tag by going in a different path. So this time I'm going to take a path from the idle to the ready one state, and we're going to take this path. So the documentation says when the tag is in ready one, if you issue a read command to the address 0, the tag should automatically go into the active state. So let's give it a try. So I'm going to close this. So bring back the tag again, select. Now I have provided a drop down list here that says a normal through ready 1 and through ready 2. We have seen the normal going through all the 3 states. This time I'm going to choose this through ready 1. Okay, and if I hit this activate, now I know that if you see this this message, I know this is the tag is activated, but let us see what has happened inside the tag. So we know we can, all these are related to the board, and just a bit of information about the first command, the antenna off. I somehow found setting antenna off good, because the tag loses the power. I know the tag is going to start all over again. So there is a command for the antenna off, but we don't see any command for antenna on. So that is taken care of by the next command. So the protocol. So how do I know this? So all this information is described in the CR95HF documentation. So it says, the documentation says, as soon as you send this ISO, as soon as you configure the board for a specific protocol, the RF field turns on automatically. So if you see here, I have sent the REQA command, you got a positive response. Then soon after that I'm sending this read address 0, and I got everything from address 0 onwards, and the 4 bytes. So it's 4 pages from address 0. And we know from the memory structure the UID, okay, the UID. And if you remember my previous videos on anti-collision, as part of this anti-collision sequence, we know how to get this UID part by part. But what about here? Now how did I get this UID? How is that I'm showing the UID here? It is because we know that the page 0, 1 and 2, so the UID is present in page 0, 1 and 2. So if you just try to compare with the with this UID 04. So 04 starts from here. So the first up to C7, so up to 4C, this is the first 3 bytes, followed by the BCC, and the remaining the 4 bytes up to 33, and sorry, up to here. Okay, we got this the continuous data. So now this is how we know the card is active. How do we prove that it's activated? Let's hit read tag, and if you're able to read it, that's fine. You're able to read and write here. So that is how you can activate the tag using just 2 steps. Let us see what's the other step says. So other step we are going to say is, from the idle state we'll go to ready 1, from ready 1 we'll go to ready 2, and from ready 2 we will go to we'll issue a read command and go to active state. So the only thing we are missing is the select 2 command. But bear in mind, in order to do the select here, you have to do this anti-collision commands. So if you don't do the anti-collision commands, you can probably come out. You can still do without anti-collision command only if you know the UID. So UID of the tag. So I've never tried this bit, but in theory, the anti-collision command returns a part of the UID which is used in the select command. So if you already know the UID, obviously then you don't need to do this anti-collision command. I've never tried that, but okay, let's see this thing. We are going to try from idle to ready 1 to ready 2 and to the active state. So because I'm using this antenna off, I don't have to lift the tag and put it back. I'm going to clear this thing for the time being. So I'm going to choose through ready to and click on activate, and let's say I have got REQA with the anti-collision 1 and got the select 1, and from the select 1 I got directly this read address 0. You're able to read it. Okay, so that's how you select and activate an ultralight tag. Let's give it a try to read again. Yep, so you're able to read it.